we have an example of a 3D object, which we call it a cube. Shape makes up the top face. Yes, Mulki, it is a rectangle. Therefore, if the shape at the top is a rectangle, what is the formula of finding the area of a rectangle? Yes, Kifa? Length times width. So we faces. And remember we said that this top part here has another face that is equal to it at the bottom that we can also use to get the total surface area is this way. Now, assuming we did not multiply by 2, assuming we did not multiply by 2, that means this one will not be there. That means we will not have this one here, and we don't have it multiplied by 2. We will also not have this one here. But still we can add the area of the three faces. That is area of the top, area of the front, and area of the side. So we are talking about area of closed cuboid and cube. With us here, we have an example of a 3D object, which we call it a cube. And we say that a cube, we may be given a closed cube or an open cube. A closed cube is when it has all the faces. And we say that cubes and cuboid, when they are closed, they are supposed to have a max or a total of 6 faces. Are we together? But when you talk about an open cuboid, that means that the part at the top is missing. So when the part at the top is missing, how many faces are we going to have? We will have 1, 2, 3, 4, and 5. So an open cuboid and an open cube has a total of 5 faces. But today we are talking about closed cube and cuboid. Now a closed cube looks like this. Let us look at a structure of a closed cuboid. We can draw it this way. So this is what we call a closed cuboid. Let us just have the other parts that are not visible. We can draw them using broken lines like this. So that cuboid. Now we say that for you to calculate the surface area of a closed cuboid, you are going to ensure that you get the area of all the 6 faces, because a closed cuboid has a total of 6 faces. But there is a way we can work out the area of a closed cuboid and a closed cube without having to calculate the area of the 6 faces one by one. So that formula, we will have to work out the area of the top part. This is the top part. Then we will work out the area of the front part, this part that is facing you. Then we will work out the area of the side part. After working out the area of the three faces, we combine them together and multiply by 2. So let us give our figure here some measurements. We are going to have the length here as 12 centimeters. This one is the width. It is 6 centimeters. And the height here, we will give it a measurement of 5 centimeters. So we have the 3 sides. We want to work out the area of the 3 faces we have talked about. So let us start with the area of the front face. So first and foremost, you have to identify that the front face that we are talking about here, it is in which shape? So which shape is the front part? Yes, Mohammed? It is a rectangle. So how do we get the area of a rectangle? Hibo, length times width. So for us to get the area of the front part, we are going to say that area equals to length times width. Are we together? And the length of the front part is a 12 centimeters. So we say area equals to 12 centimeters times what is the width? Yes, Muhammad. The width is the front part is here. Remember, we are talking about the one that faces us. So what is the width here? The width is going to be 5 centimeters. We are not talking about this width. The front part is here. So we have just extracted the figure or the shape here alone. Remember, when we extract this shape here, we will not use the width down. So we say area equals to 12 centimeters times 5 centimeters. What do we get? If we multiply 12 centimeters by 5 centimeters, we get an area of 60 centimeter squared. That one you are done with the area of the front part or the front face. Let us talk about the area of the top face, which is here. So area of the top face. Identify which shape makes up the top face. Yes, Mulki, it is a rectangle. Therefore, if the shape at the top is a rectangle, what is the formula of finding the area of a rectangle? Yes, Kifa? Length times width. So we say area equals to length times width, which is going to be, what is the length of the top part here? Mohammed? 12 centimeters. Very good. And what is going to be the width now? The width is this part that is moving up this way. What is going to be the width? Yes? 6, because this part here is equal to this part. So if this part is 6, therefore this is also going to be 6 centimeters. So we multiply by 6 centimeters, which is going to give us an area of 72 centimeters squared. Very good. So already we have worked out the front and the top. We are left with the area of the side face. We have it here. So how do we get the area of the side face? Identify the shape that makes up the side face. So the side face is made up of which shape? Rectangle again. So for us to get the area of a rectangle, we use the formula length times width. What is going to be the length of the side face? 6 centimeters. Very good. And the width of the side face is yes, 5 centimeters. If we multiply 6 centimeters by 5 centimeters, we get an area of yes, 30 centimeters, and it is squared. Now, we have the area of the three faces, and remember we said that this top part here has another face that is equal to it at the bottom. The front part has another face that is equal to it at the back. Then the side part has the other part that is equal to it on this other side. So both sides appear in a 2, 2, 2. Are we together? They are in a pairs. So one of the ways of getting the total surface area, we can decide to multiply this by 2, multiply this by 2, and multiply this by 2. because we have two parts that are similar with this, two parts are similar with this, and then two parts are similar to this. Are we together? So when we multiply by 2 by 2 by 2, we will get the total surface area. Let us multiply 60 times 2. You get a total of 120 centimeter squared. Then 72 times 2, we get a total of 144 centimeter squared. Then 30 times 2, we get a total of 60 centimeter squared. Then we can now add whatever we get as the final area after multiplying by 2. So we have a total surface area as 120 centimeters squared plus 144 centimeters squared plus 60 centimeters squared. What do we get here? 0 plus 4 plus 0. We get 4. 2 plus 4 is equals to 6 plus 6. So we write here 2 carry 1. 1 plus 1, 2 plus 1. So the total surface area is 324 centimeter squared. That is the total surface area of this figure if it is closed. Or the other way that we can also use to get the total surface area is this way. Now, assuming we did not multiply by 2. Assuming we did not multiply by 2, that means this one will not be there. That means we will not have this one here, and we don't have it multiplied by 2. We will also not have this one here. But still we can add the area of the three faces. That is area of the top, area of the front, and area of the side. What is the area of the front? 60 centimeter squared. The area of the side is 72 centimeter squared. Then the area of this is the area of the top. Then the area of the side is 30 centimeter squared. Now if we add this, what do we get? 0 plus 2 plus 0, we get 2. 6 plus 7 is equals to 13. 13 plus 3 is 16 centimeter squared. Are we together? Then after adding the three parts, that is the top, the front, and the side, we multiply it by 2. So we want to see if we are still going to get 324. We have 162 centimeters squared times 2. Now 2 times 2 gives us 4. Write 4 there. Do we carry anything? No. So 2 times 6 we are going to write what? 2, then we carry 1. 2 times 1 gives us 2. Then 2 plus 1, 3. So we are getting 324 centimeter squared. Very simple. What is the formula of working out the area of a closed cube and cuboid? Very simple. Do we have this one here? Now, if you want to work out the area of a closed cube and cuboid, area of the top plus the area of the front plus the area of the side, then you multiply by 2. Are we together? Are we getting each other? So that one you will have worked out the area of a closed cube. The same applies to the area of a cuboid. Not a cube and cuboid. Are we together? But now, one thing that you should know is that for a cube, all the faces are equal. So for a cube, it is even going to be much easier. You don't have to work out the area of the top, the front, and the side because they are all equal. So we can work out one area and multiply by the number of faces. Are you together? So how many faces do we have in a closed cuboid cube? 6 faces. If you work out the area of one face and you multiply by 6, you will have gotten the total surface area of that cube. Is that okay? Now I want to give you one example. You try. And the easiest way of drawing a cuboid, just draw a rectangle and you make sure your rectangle is a good rectangle. After drawing one rectangle like that, we will draw another one, but make sure the other one cuts into the previous one that you have just drawn. So it will take a portion of the one that you just drew in the beginning. So you're going to draw it this way, then down, and make sure that the sides are almost equal. Let us have a good figure like that. Then we join the parts this way. This corner, join it to this one. This corner, join it to this one. This corner, join it to this one. And this corner, we join it to this one. We will have gotten our cuboid. And since it is a 3D object, meaning that these other sides, we cannot see them, we can use dotted lines for the parts we cannot see. So that is how we are going to have it. Then we will give it the measurements. So here we will say millimeters. That is in the length. Our width will be 10 millimeters. And our height will be 20 millimeters. The instruction is find the surface area of the figure of the closed cuboid. Above. Find the total surface area of the closed cuboid above.